So we want to talk about forms of linear equations now. So we've talked about slope, and slope is an important part of a linear equation, but it's not the whole thing. So we want to talk about a couple of different linear relations expressed in either slope-intercept form, which we're going to talk about in this video, general form, and slope point form. So we'll talk about three different forms in three different videos. This one will cover the first one, the slope-intercept form. And what we're going to try to do is use the graph to find the equation, or use the equation to find the graph. That's essentially what we have to be able to do. So we're going to look at this one first, then we'll look at another video at that one, and a third video about the general form. But we're looking at y equals mx plus b. So that form is important to recognize as these two things are parameters. Okay, so this is called the slope. We know that, all right? That's the m. This b value corresponds to our y-intercept, all right? And the y-intercept is the place where the graph, where the line intersects the y-axis. So we want to be able to graph and get an equation. That's what we want to be able to do. So we want to be able to find the slope. We know how to do that now. Then we want to actually be able to translate that into an equation, all right? And also draw the graph of an equation. So there's a couple different ways to draw a graph. And one of them is to take the slope-intercept form, so this is y equals mx plus b, and use it to actually create a table of values. So to do that, what we do is we just pick some x values, okay, and we plug them in, or substitute them into the equation. So if x is minus 3, I'm just going to show you this one, then what we do is we say, what's y? So we go 3 times minus 3 plus 4, minus 4. Try to make this, maybe just write this a little bit bigger too, so I want you to be able to see it well. So y equals 3 times minus 3 and then minus 4. So that gives me minus 9 minus 4, and that gives me minus 13. So that's my first point. And you might be wondering, well, where do these x values come from? You can pick whatever x values you want. That's the beauty of creating a table of values. I have selected points that are around 0. That are small, basically, all right? You can see that. So that's why I've chosen minus 3, minus 2, minus 1, 0. You don't have to even choose that many if you don't want to, but I'm going to just pick a bunch so you'll see them on the line. You only need 2, theoretically, all right, to draw a line. You need 2 points, but table of values, we're going to do a few more. So we have 3 times minus 2 now. That's minus 6 minus 4, and that gives me minus 10. Okay, then if I plug in x equals minus 1, you get y equals 3 times minus 1 minus 4. So that gives me minus 3 minus 4, and that gives me minus 7. And then I think you can probably recognize the pattern. We'll do one more when x is 0. We go y is equal to 3 times 0 minus 4, and that gives me minus 4. And you'll notice, hopefully now, that there's a pattern. And the pattern is that everything is just jumping by 3. We're adding 3 here, then we're adding 3 here, then we're adding 3 here, and so we're going to continue to do that. So for these ones, instead of plugging them into the equation, I'm just going to keep this process alive. I'm going to add 3, and I'll have minus 1. I'm going to add 3 again, and I'll have 2, and I'm going to add 3 again, and I'll have 5. And then what we do with this is we plot those points. So I think this grid is 10. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. I guess it's 12. So I'm going to plot just the minus 13 isn't going to fit, and I don't really need it. I'm going to go to minus 2 and minus 10. So that's my first point. And then minus 1 is at minus 7. So that's minus 7 is right here. So minus 1 and minus 7 is right there. Then at 0, it's at minus 4, which is right here. Then at 1, it's at minus 1, which is right here. And then, excuse me, at 2, it's at 2, which is right here. And then at 3, it's at 5. 1, 2, 3, 4, 5. So it's right there. And then essentially, you're going to draw a line through all of those points. So I'm going to try to draw that line through those points. And that's my graph. Okay. Now, obviously, I'm cheating a little bit because I have a smartboard that's allowing me to draw a straight line. You need to use a ruler to do that. Okay, but that's the idea of getting a table of values. And again, you can shorten your table of values. You don't need 1, 2, 3, 4, 5, 6, 7 points. You can have maybe 4 points or 2 points is the minimum. And you can also have more. You don't need just 7. You could have as many as you want, but you really don't want to do more work than you have to. So you notice this one, I've actually shortened my table of values now to only have 5 instead of 7. So I'm going to do the same thing, and I'm just going to plug in my values. So I'm going to take, when x is minus 4, I'm going to say, what's that going to be? All right, same idea as the last one. We're just plugging numbers in. So we're going to go y is equal to then minus 1/2 times minus 4, and then plus 8. So half of 4 is 2, and the negative cancel. That's why I'm getting a positive 2. So I end up with 10. So this is going to be 10. Then if x is minus 2, you'll notice, why am I jumping by 2? You might be wondering why I'm doing that, because before I was jumping by 1. And the reason I'm doing that is because of this 1/2. So I want nice numbers to come out. I don't want to have halves in there, so I'm going by 2 because half of 2 is 1. All right, that's why I'm doing that. So if I put in minus 2 and then add 8, then minus 1/2 times minus 2 is 1 plus 8, and that's going to give me 9. So that means the pattern is going to continue. So I'm just going to jump by 1 each time, but jump down by 1. Okay. So then I'm going to plot these points. So at minus 4, there's 1, 2, 3, 4. There's minus 4, and I'm going to go up to 10. This thing goes up to 10. 5, 6, 7, 8, 9, and then there's 10. So I'm going to go up to 10, which is right here. Then minus 2 is going to be at 9. Then 0 is at 8. Then 2 is at 7. And then 4 is at 6. And again, you can get your ruler out and draw a line through those points. Make sure that it goes through all of them. It should go right through the middle of all of them. Okay, assuming that you've drawn it well. And there's your graph. And then you should put arrows on the end of those because it does continue forever. All right, so that's how you use a table of values. Now, the thing about this is that when you write this equation, it actually gives you a couple of points. It gives you the slope, but it also gives you the y-intercept. So we can actually create equations from word problems, and we can also graph them without too much thought. So instead of using a table of values, because you probably have noticed that it takes a little bit of time, we can actually draw these much more quickly. Okay, and we can write equations much more quickly. So it says the graph of a linear function has a slope of 3/5. So I'm going to write that down. M is 3/5. Okay, and then it gives me a y-intercept of minus 4. So that means b is minus 4. So I can then write my equation, y equals mx plus b, really quickly, because I can just go 3/5 of x and then minus 4. And that's my answer. Okay, that's my equation, because I know my slope and I know my y-intercept. So the slope-intercept form lets me write out really easily equations if I'm given them in word problem form, where I'm given those two pieces of information. I'm given the slope and the y-intercept. Now, the next part of this, it makes it much easier to draw as well. So instead of doing a table of values, what I can do is, that's my y-intercept. So I know that point. So I go 1, 2, 3. There's my y-intercept. And then this is rise over run. You remember that from the slope video. So what I do is I just use the slope from there. So I run 2 and I rise 1. Okay? And I get my second point. And so this is 3 and this is 1, 2. And again, you should put labels on your axes. You should make a nice graph, put a scale on there. But then we're going to draw a line through those 2 points, because we only need 2, right? We only need 2 points to draw a line. That's all we need. More is great, but we only need 2. So we're going to draw our line through those 2 points, and there's our equation drawn. So it's much more efficient, I guess, than doing a table of values. All right, graph the y-intercept, and then from the y-intercept, just rise and run whatever your slope dictates, and then plot that point, that next point, and then you're done. You just connect those two with a line. Okay, so instead of using a table of values, which we did earlier, this is much quicker. So if we look at another example, okay, our y-intercept, there's our y-intercept, it's 2. So what I'm going to do is I'm going to say this is my x-axis, this is my y-axis. Here's 1, here's 2. Okay, so there's my y-intercept, and then let's go 1, 2, 3, 4, 5. We'll just kind of label a little bit of these. 1, 2, 3, 4, and 5. There's -5, and we'll go up here. That's 2, so that's 3, 4, 5, and then we'll go down. So 1, 2, 3, 4. Let's go down to -5. All right. So you can put more in there, but for our purposes, we'll just do that. So we're starting our y-intercept. This is our rise and our run. So our run is 4. Okay, so I'm going to run 4. So there's 1, 2, 3, 4. And then this is my rise. My rise is negative, so that means I'm going to go down 3. So I'm going to go down 1, 2, 3. Okay, so there's my next point. And then I'm going to draw a line through those 2 points. And again, I'm cheating, but you can have a ruler and plot those points, and then there you go. There's your line. Okay, and we should, again, put arrows on the end of our line. I can do it, ask the calculator or computer to do it, I mean, but I'll just put them on there with my marker. So there's another graph. So that's the concept of graphing a linear function. When you have the slope and the y-intercept, it's much quicker than using a table of values. Can you use a table of values? Absolutely. Can you always use a table of values for any graph that you want to draw? Yes. But it's just not efficient. It's not quick. This is much quicker. Okay. Now the other way of going is, what if I give you the graph and tell you to give me the equation? Okay, so to do that, you still need the 2 pieces of information. You need the y-intercept, which is right here in this case. So the y-intercept, our b value is -4. And then the other thing you need is the slope. So the slope, you're going to calculate from 2 points. I'm going to go this point here because it's on a grid line, and this point here. Okay, so the slope is my rise over my run. So my rise is going to be 1, 2, 3, so -3. Over my run, and my run is 1, 2. So I have my slope and my y-intercept, so I can say therefore my equation is y is equal to m, which is -3 over 2x, plus b, and b is -4. So actually, instead of writing a plus, I'm just going to write a -4. And that's my equation. Okay, same thing here. We're going to just look at another example. So again, first thing you got to do is identify, there's my y-intercept. So my b value is -3. Okay, and then I'm going to do rise over run. Now I notice this point goes through a grid line. So if I run 1, I rise 1, 2. Okay, so my slope, which is rise over run, is when I run 1, I rise 2. So the slope is 2. So that means my equation is y is equal to mx plus b. So y equals 2x minus 3. Okay, and again, just so you know where this is coming from, right? This is my general equation, mx plus b. So my m was 2, that's where I got that from, and my b was -3. Right, so that's the concept of both graphing a line using the slope-intercept form and getting the equation from the graph for slope-intercept form. There's a number of different questions here. I'm not going to go through each one of these, okay? But I'll just sort of show you an example. It says write an equation or which equation matches each graph. So what I'm going to do, the first thing I'm going to do is identify where's my y-intercept. My y-intercept here is at +1. So that means it's not this and it's not this, okay? Because they don't have y-intercepts at +1. And then of these two, these are my two options. This slope is negative, that slope is positive. So if I run 1, I rise 1, 2, 3, 4. Okay, so I rise 4 when I run 1. That means the slope is positive 4, so it's this equation that matches that graph. All right, so that's the idea. So just identify the slope and the y-intercept, and then you can go on from there to get the equation. So I'm going to leave those with you. There are a couple more slides in this presentation, and I'll just show them to you so you can have that practice. Okay, but I'm not going to go through these. These are your exercises to try on your own. And you can pause the video as you do it so you can see these questions and try them on your own.